Hey guys, it's Mrs. Conway. So today we're going to go over radicals. Now, hopefully you kind of figured out how to deal with what the connection is between a radical and a fraction. If you haven't, just a little side note, if you have a radical that's like the a root of x to the b power, that's the same thing as x to the a over b power. That's sort of the fractional exponent rule. So this is how this ties into exponent rules, which is what we just finished up. So some vocabulary here. If you have a radical, which is this square root here, this is actually, you've so far learned about square roots. It turns out you can use roots for anything. So this symbol means radical, although you will hear me refer to it as a radical or a root sort of interchangeably, but radical is the official name. The number in front of the radical is called the index, and that just tells us what power we're undoing. Normally it's a 2, and we're undoing power of 2. Sometimes it's other numbers. And then this number, which if it was an exponent would be the base, we call it the radicand when we're talking about radicals. So radical, radicand, index. If there is no index written, it's assumed that it's a 2, and we're talking about square roots. And just a little note here, we're going to not worry about negative roots right now. So you might want to write yourself a note here, roots undo powers. So for instance, the square root of x squared is just x. So it's important if we're going to be talking about square roots that we think about our perfect squares. These are the numbers that if you had, for instance, 4 items, you can arrange them in a square. So items that can be arranged into squares, also they're numbers that are whole numbers to the power of 2. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Ideally, you should have these memorized at least up to 15, if not 20. So I'm going to list them all out here, and you make sure you have them written down. You're going to need them for this. You might even want to put them on like a note card or somewhere where you can access them quickly. So that's the first 12. I'm going to list the first 15 because that's how many I think you need to have memorized. After 12, 13 is 169. And then the cool part is 14 is just 196. And then 15 is 2. So there's our perfect squares. These are numbers that we can just square root them, hopefully in our heads, if not in our calculator. Now, let's just practice doing square roots then with numbers that square root easily. So for instance, the square root of 16, that's the 4th one. So the square is just 4. That's it. Now, 2 times the square root of 121. That's what this reads. This is not the same as an index. When it's an index, you'll be able to tell. It's going to look different. See how this little tiny 3? That's an index. This here just means 2 times. So you're going to do 2 times, the square root of 121 is 11. 2 times 11 is 22. So there you go. So now hit pause, try 3 and 4. Okay, hopefully you tried 3 and 4. You should have got for 3, 6 times. Now 289 is not up here, so you would have had to actually figure it out, but 289 is actually 17 squared, and then 6 times 17 is 102. So you should have got 102 for number 3. And then hopefully for 4, we didn't actually go over 400 either, but I hope it's clear that 400 is 20 squared, so you have 3 times 20, which is 60. All right, so hopefully those make sense. Hopefully those are pretty easy because that's really not the point of this lesson. You should already know this stuff. But there is some practice for that as well on Delta Math. If you want to pause and do that now, just practice remembering your perfect squares. What we're really after here is simplifying non-perfect square roots. So when you have a number like 32, if I were to try and take the square root of that, I would quickly notice that it's not on my list. In fact, it's somewhere between 25 and 36. So we could guess that it might be somewhere between 5 and 6, 5 point something. And in fact, if I put it in a calculator, I'm going to get a decimal answer. So if I take the square root of 32, I'm going to get 5.656854249. Now, some of you might already have guessed this is actually never going to stop. This is one of those numbers that never, the decimal keeps going. The pattern of the numbers never repeats. So it's non-terminating, non-repeating. It's an irrational number. There's no way to write this number down without rounding it. And sometimes it's not appropriate to round. So we have to learn how to deal with these in a way that we can. Now it's important, one thing to be able to do is just to be able to estimate what the value is by looking at it, knowing it's between 25 and 36, so we know it's between 5 and 6. But the other way that we deal with these is a lot like simplifying fractions. We're going to square root the parts that we can. So we're going to break 32 up into two numbers multiplying, one of which we can square root. So what I'd like to do is I like to take my list of perfect squares and find the largest perfect square that the radicand is divisible by. And it's really important that you pick the largest perfect square. Otherwise, you're going to have extra work to do. So if I look up here, 32 isn't very big. So I know that I'm probably not going to need, 32 is not divisible by 36. It's probably not divisible by 25 either, because this ends in a 5, so anything that would be divisible by 25 would need to end in a 5 or a 10. So I'm going to do 32 divide 16 and see if 16 goes into 32. Some of you might already know the answer to this, and that's good. 32 divide 16 is 2. So that means that 32 can be broken up into 16 times 2. Now the cool thing about square roots is that with multiplication, I can square root two things that are multiplied separately. So if I have the square root of 16 times 2, that's the same thing as the square root of 16 times the square root of 2. So now I can just do the square root of 16, which we know to be 4, and then I just leave this as root 2, and that's my answer, 4 root 2. And that's all there is to this. Now, they can get harder as they're bigger. Finding the number that's the perfect square, that's the biggest one that goes in, can be the hardest. So a tip that I have for you is take your original number, divide it by 2, and use that as your basis to start. So for instance, 180. I'm going to divide 180 divided by 2, and that's 90. Now if you get a decimal, just know 90. And so then I'm going to come up to my perfect squares, and I'm going to look for 90s between 81 and 100. So I'm going to start with 81. So always start with a number that's less than half or exactly half of the number you have. So I'm going to take 180 and I'm going to divide it by 81. Doesn't work. See, I get a fraction. That means that 81 does not go into 180. Remember, divisible means it goes in evenly. So if I divide it, I should get a whole number. So now I'm going to try the next perfect square down, which is 64. So I'm going to take 180 divide 64. I got another fraction. Try again. 180 divide 64. Nope, sorry, new number now. 180 divide 49. Doesn't work. 180 divide 36. Yay, I got a whole number. So that means I come down here, and I'm going to rewrite this as 180. I'm going to rewrite it as the square root of 36 times the square root of 5. So you put your perfect square and the number you multiply your perfect square by to get the original number. These two numbers should multiply to this one, and one of these should be a perfect square. Okay, so now I just do the square root of 36, which is 6, and then root 5. And that's it. So I want you to try 7, 8, and 9 on your own. Hit pause, try them out, see if you get the right answers, and then I'll go over how you would do 10. So hit pause, try 7, 8, and 9. Okay, hopefully you've completed 7, 8, and 9. You should have gotten root 49 and root 3 for number 7, which reduces to 7 root 3. You should have got 175 breaks into 25 and 7. Square root of 25 is 5, so you'd have 5 root 7 for number 8. And for number 9, you should have found that 48 is 16 times 3, so you have 4 root 3. Now if you got, if you took out 4 from 48, then you ended up with 2 root 12. That means that you didn't pull out the biggest numbers, so you're going to have to either keep going or start over again and grab 16 this time. So make sure you always find the biggest perfect square. Okay, number 10 looks a little different because there's a number outside the radical. Well, if you remember up here when we had a number outside the radical, it was just multiplication. So we're going to do the same thing here. We're going to do the square root of 54 like we've been doing, and then just multiply the outside number by 2 when we're done. So 54, the biggest perfect square that goes into 54 is 9. So it's going to be square root of 9 times square root of 6, just with a 2 out front. Now I do 2 times the square root of 9 is 3, times radical 6. 2 times 3 is 6. Root 6 is our final answer. And that's all there is to it. So if you want to try a couple more for practice, you can take a look at, you can try numbers 11, 12, 13, and 14. Or if you're feeling ready to go, just go start working on the delta math. If you want to hit pause really quick, try those out. I'll show the answers in just a second. And then I'll briefly show the answers for these perfect cube ones on the bottom. The perfect cube stuff is extra credit. So if you're not interested in doing the extra credit, you can stop watching the video now and just go get to work on delta math. If you want to know how to do perfect cubes, you can always come back to the video and watch it from here when you're ready to do perfect cubes. Okay, so hopefully you've had a chance to work out numbers 11, 12, 13, 14. So here's what you should have got for those. 11 should be 25 root 6, negative 25 root 6. 12 is 64 root 2. 13 is negative 6 root 7. And 14 is 32 root 6. Now, if you're interested in doing the perfect cube ones, you might want to start by listing out the first 10 perfect cubes. So 1 cubed is 1. And remember, cubes is to the power of 3. So I'm talking 1 to the power of 3. And then 2 to the power of 3 is 8. 3 to the power of 3 is 27. 4 to the power of 3, I'm checking because I always mess this one up, is 64. 5 to the third is 125. And then here's where I start needing a calculator. 6 to the power of 3 is 216. 7 to the power of 3 is 340, 12. 9 to the power of 3 is 729. And 10 to the power of 3 is 1000. Hopefully you can figure that one out. I'm going to go ahead and 3, 4, 5, 8, just so that I remember where those go. All right. And again, you don't actually have to be able to do cubes. I just am showing this for the people who are interested in doing the extra credit at the end of the delta math assignment. So if you're not interested in perfect cubes, stop watching this video now and go practice your square roots. So the cube root of 8 should be clear is 2, because cube root is just like square root but undoes power of 3. So the cube root of 8 is 2. And then here 5 times the cube root of 343, which is 7, is going to be 35. Here we have the cube root of negative 27. Now, if it's a square root, you can't square root negatives. But this is a cube root, so you can do the cube root of a negative, and it is going to be negative. So it's going to be negative 3. And then same thing here. We've got 2 times the cube root of negative 1000, which is going to be negative 10. So you end up with negative 20. All right. Again, that was the easy stuff. So now you got to try it with the harder stuff. Now, it's the same process we've been doing. You're just using your cubes instead of your squares. So here, we've got the cube root of 40. Well, 40, which of these could go into 40? Well, we could try 27, but that seems like that's going to be too big. Yeah. 40 is divisible by 8, though. So you can break that into the cube root of 8 times the cube root of 5, because 8 times 5 is 40. Cube root of 8 is 2, so you've got 2 cube root, and that's it. So you might want to try 20 real quick before I do it. 192 divide 64 is 3. So I've got the cube root of 64 times the cube root of 3. The cube root of 64, remember we're doing cubes, not squares, is 4. So I've got 4 cube root 3. And then if you want to go ahead and try now, you probably would be able to do the Delta Math assignment. So you can go ahead now, go on Delta Math, give that a try, and good luck.